Hi, my name is Nico Beatty, and this is my Lab 4. So for our introduction of our circuits, we were to predict how the circuits with resistors and capacitors would behave in a series and parallel circuit. We would then use the multimeters, such as the ammeter and the voltmeter, to measure the values of the different conventional currents and the potential differences in the circuits. So for our key concepts and principles, we are using Ohm's law, which is delta V is equal to I times R. We were also using the capacitance formula, which is delta V is equal to Q over C. And then we would be using the node rule, and we would be using the Kirchhoff's loop rule, which is the sum of all electrical potential differences around the loop is equal to 0. So if you look at the first one, that is equal to the capacitance formula, and then the one at the bottom is equal to Ohm's law. So for our experimental setup, we were to predict the currents of I1 and I2. And here we have what the equilibrium is for R, which is 147 ohms, and I is equal to 3 over 147, which will give us 0.02 amps. So our prediction was that in flipping the switch, there wouldn't be a change in the amps. And when we did it, we had our prediction as correct. At one point, we read that there was 0 amps because it was an open circuit. So why doesn't the ammeter reading change? Well, it's because there's a high resistance, so there is little current flow that goes through it. It barely changes as current, and as is the rest of the circuit is almost the same. So what is the ammeter reading at 100 ohms? Both ammeters read approximately 0.08 ohms, and for our data that we collected, we found that the one for the wire and the ammeter is equal to 0 ohms. So for the RC circuit, what happens to a bulb when a battery is connected in a series RC circuit? It becomes bright and then it dims until it shuts off. And the same thing actually happened whenever we connected it to a series to a charged capacitor. It was bright and then it started to dim before eventually shutting off. So what happens to it whenever the current and the circuit for both are above? Well, there's a large amount of current, but then it starts to slowly decrease. As seen, we have the time for the capacitor to charge with bulbs of 10 ohms and 20 ohms, and it approximately took almost double as the ohms doubled as well. So for our calculations, when we look at our slope and for our graph, we have that the slope is equal to negative 0.1664. And for our RC, we found that negative 1 over slope is equal to 6.09. And this is just using the formula that we were given. We found that 30 ohms times 0.2, F is equal to 6. So for our reflection questions, what would be different about hooking it up to a real ammeter, and how would it have affected the circuits that we hooked it up to? There would be a drop in the voltage, and it would be lower than what we expected it to be. And this is due to the fact that there's some slight resistance for the capacitor. And the reason why there's some slight resistance and why it wouldn't even reach full charge, which is in our second question, is because the capacitor has batteries that have internal resistance. So it would take much longer for the capacitor to reach full charge. Thank you very much and have a great day.